For this problem, it says, show that the function f of x is equal to the square root of x satisfies the hypotheses of the mean value theorem on the closed interval 925. Well, let me just give you a rough sketch of what this function looks like. The square root of x basically looks like this function. And the reason why there's no negative values is because when you take the square root of a negative number, it is imaginative, right? It's an imaginary number. It's I. It doesn't exist. So the function, notice, does not exist, or it's undefined for numbers less than 0. So you have to watch out if you can really apply the mean value theorem to this situation. But thankfully, notice that the interval that I'm using is 9 to 25. Well, the square root function is continuous. Remember, that was part 1. It's got to be continuous. And it is differentiable on that interval. So we're okay. So we can apply the mean value theorem in this case because those two conditions are met. So the first thing I want to do is state the theorem. Basically, it says that there's a point C such that the derivative of C is equal to the slope of the secant line, which is basically this formula right here. Well, I'm going to break this up into parts. First thing I'm going to do is find the value of the slope of the secant line segment. So I'm going to do f of 25 minus f of 9 over 25 minus 9. F of 25, so plug in 25 into the function. The square root of 25 is 5. Plug in 9. The square root of 9 is 3. And then we'll have 25 minus 9, which is 16. 5 minus 3 is 2. So 2 over 16, which reduces to 1/8. So what the mean value theorem says is that there is some point, that there has to be some point between the numbers 9 and 25 such that the derivative at that point is 1/8. So we need to figure out what that point is. So I'm going to take the derivative of my function. The derivative of my function, you can rewrite the square root of x as x to the 1/2. Take the derivative of this, so bring the 1/2 power down. This will be x to the 1/2. Basically, what it's saying is that 1/2 x to the negative 1/2 is going to equal to 1/8. That's some value of x. So what I'm going to do is I'm going to set these two equal to each other and solve for x. Notice this is a negative exponent, so I'm just going to rewrite this as 1 over 2 times the square root of x equals 1 over 8. Notice I've got a nice little proportion, so I'm going to cross multiply, and I'm going to get 8 equals 2 square root of x. To solve this for x, I'm going to divide by 2, and I'm going to get 4 is equal to the square root of x. And then to solve this for x, I'm just going to square both sides, and 4 squared is 16, so I get x is 16. So basically what the mean value theorem says is that the derivative of my function at 16 is equal to 1/8. And if you notice, 16 is in between the interval 9 to 25. So that is my point.